This is the first time astronomers have observed a white dwarf star that is consuming both rocky metallic and icy material, the ingredients of planets. Archival data from NASA's Hubble Space Telescope and other NASA observatories were essential in diagnosing this case of cosmic cannibalism. The findings help describe the violent nature of evolved planetary systems and can tell astronomers about the makeup of newly forming systems. The findings are based on analyzing material captured by the atmosphere of the nearby white dwarf star G23844. A white dwarf is what remains of a star like our Sun after it sheds its outer layers and stops burning fuel through nuclear fusion. The findings are also intriguing because small icy objects are credited for crashing into and irrigating dry, rocky planets in our solar system. Billions of years ago, comets and asteroids are thought to have delivered water to Earth, sparking the conditions necessary for life as we know it. The makeup of the bodies detected raining onto the white dwarf implies that icy reservoirs might be common among planetary systems. Theories of planetary system evolution describe the transition between a red giant star and white dwarf phases as a chaotic process. The star quickly loses its outer layers and its planet's orbits dramatically change. Small objects, like asteroids and dwarf planets, can venture too close to giant planets and be sent plummeting toward the star. This study confirms the true scale of this violent chaotic phase, showing that within 100 million years after the beginning of its white dwarf phase, the star is able to simultaneously capture and consume material from its asteroid belt and Kuiper belt-like regions. Death of a planetary system. When a star like our Sun expands into a bloated red giant late in its life, it will shed mass by puffing off its outer layers. One consequence of this can be the gravitational scattering of small objects like asteroids, comets, and moons by any remaining large planets. Like pinballs in an arcade game, the surviving objects can be thrown into highly eccentric orbits. After the red giant phase, the white dwarf star that remains is compact, no larger than Earth. The wayward planets end up getting very close to the star and experience powerful tidal forces that tear them apart, creating a gaseous and dusty disk that eventually falls onto the white dwarf's surface, Johnson explained. The researchers are looking at the ultimate scenario for the Sun's evolution, 5 billion years from now. Earth might be completely vaporized along with the inner planets. But the orbits of many of the asteroids in the main asteroid belt will be gravitationally perturbed by Jupiter and will eventually fall onto the white dwarf that the remnant Sun will become.